Okay, sir.
10.0.0.0 300 hosts per subnet. That's the question. We need at least 300 IP per subnet. How do we do? Let me show you. 10 dot 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. So we got 24 bits in our hand for host. We don't want all these 24 bits. We just want 300 host. So we need bits which is really needed only for 300 hosts. This 2 to the power of 24 will give millions of IP. We don't want that many. We just want 300. So we want to see how many bits we need for 300. We all know that if I take this bit, I'll get 2 plus 1, 3. 3 IP. And if I shift 1 here, then it's going to be 4 plus 2 plus 1, which is 7. Earlier I said 3, now I'm saying 7. If I shift 1 more bit, it's going to be 8 plus 4 plus 2 plus 1, which is 15. Earlier I said 7. Before that I said 3. If you see here, it's doubling. And again, if I shift 1 more, then it's going to be 16 plus 8 plus 4 plus 2 plus 1, which is 31. Earlier I said 15. Before that I said 7. Before that I said 3. So if I take the whole octet, I'll get 255. I'll get 255. And if I take one more additional bit, it has to double, which will be 512. That's what I want to say. The whole octet, 8-bit, is not sufficient for us. We got 300 hosts, 300 IP address, not sufficient. We take another bit from here so that we can get 300. We'll get up to 512. In another word, if I need to say, this is 1, this is 2, this is 4, 64, 128. Now, you see, this dot is only for our convenience. What is the size of IPv4? 32-bit. It's not 8-bit dot 8-bit dot 8-bit dot 8-bit. It is 32-bit. For our convenience, it's 8-bit dot 8-bit dot 8-bit dot 8. So this is supposed to be 100 and, so if this is 120, this is supposed to be 256. Doubled. 8, 16, 32. And then this will also double. 512. And goes like that. If I take these many bits, I'll get 255. I told you, no, you don't need to add and see. You see the next one. If the next one is 256, then the sum of the previous bits will be one less than that, 255. Now, 255 is not sufficient. We need 300. So if you take all these bits, you should get 511 because the next bit place value is 512. What I'm trying to say here is for 300 hosts, you need this 9 bits. So you're going to give from here for the sake of networking. And the face value on that place is 2. So the increment value should be 2 in the third update. Our first subnet will be 10.0.0.0/23. Do you know why it is 23? The default mask is 8. This is another 8. This is another 7. 23. Given for network. This is the first subnet. The next subnet will be 10.0.2 will come in the third update. 0/23. It goes like that. I asked you to write only the first 4 and the last 4. Let me write it for you. You correct it. 10.0. Increment of 2. So 4.0/23. 10.0.6.0/23 goes like that. The last will be 10.0. No, 10.254.0. Why 254.0? Because 1 bit is given for host. Only 7 bits are left. 254. And when all the host bits are on, we don't use it. When all the borrowed host bits are on, we don't use it. So when you go from down to top, you need to decrement 10.255.252.0, 10.255.250.0, 10.255.248.0. Am I right, Santosh? Did you get the same?
Yes, sir.
Excellent. Excellent. Okay. Now, the final touch in subnetting. I'm not going to do that today. We'll give a break for subnetting. We'll get into another easy topic. So subnetting is actually over, but the final touch we called as VLSM, variable length subnet mask, which we will not do today, we'll do tomorrow. The reason is I want you to keep remembering this for long. If I finish it today, we may remember today, but tomorrow we will forget. Whatever you did today, you need to recall tomorrow. So let's keep the final touch of subnetting tomorrow. Today, I'm going to take you to a topic called switching. Switches or layer 2 device. What layer is router? What layer is router in OSI?
Layer 3.
Exactly. Routers are called as layer 3 device. Switches are layer 2 device. What about firewall?
Firewall, I think it's also
I'm sorry,
layer 3.
Sandosh? What about firewall, Sandosh?
It's a transport layer.
Okay. Of course, but there are firewalls which can work from layer 2 and above, but most of them are layer 3 and above. Firewalls can work from layer 3 till layer 7, application layer, from network layer to application layer. But there are some firewalls which can support even layer 2. Jesus, sorry. So what I'm trying to say here is firewalls operate on all layer. Why do we call switches as layer 2 device? The routers take decision using the IP address of the incoming packet. When packet is received on a router, the packet is coming with source 10.0.0.1, destination 20.0.0.1, and the packet actually has got much more thing like source MAC address, destination MAC address. A router will not decide the exit interface. Router won't decide the exit interface using the MAC address. It see the network. Okay, 20. Let's say 20 is in this direction, 30 is in this direction, 40 is in this direction, 10 is in this direction. So it looks into the network portion of the IP and decides the direction of the packet. Whereas switches look into the destination MAC address to decide the exit interface. Switches look into the destination MAC address. See, both are receiving the same packet, but switches they don't focus on the IP layer, the network layer of the packet. Rather, it focuses only on the MAC address. The same packet, when it is received on the router, it is focusing on the IP address, the destination IP address. Now let me come to a firewall. Firewalls, they not only focus on IP address, there may be route. IP address may be available to be taken a decision, but firewalls are not going to take decision just by using IP address. Sandesh said transport layer, which means port number. Yeah, again, traditional firewalls, they will use port number, IP address, port number. But today's firewall, as I said, even the application layer, it will look into the application and decide whether to allow the packet or not. I repeat, the traditional firewalls, they will decide whether to permit or deny just by looking into IP address and port numbers, which is layer 3, layer 4. But the next generation firewall, say for example Palo Alto Networks, those firewalls, they will even look into the content of the packet and see what application this packet is, or from which application the packet is generated, and it will even see the content that is going inside that packet, based on which the decision will be made whether to be forwarded or dropped. You see the differences. Routers, they just need IP address to route the packet. That's the decision maker. That's how the control plane works. You know what is control plane? The factor that controls the forwarding of traffic is control plane. What is that controls here? In router, IP address controls. Based on IP address only, the decision is made in router. Whereas in switches, it's the MAC address. MAC address is used to decide. Whereas in the firewall, MAC address is needed, IP address is needed, port numbers are needed. On top of all this, you can also make the firewall to consider the application, the content. You see? So the control planes are not same for all network device. For the firewall, the control plane decides by looking into almost all layer and then decides whether to forward it or drop it. Santosh, did you get it?
So is it called control plane or
Plane,
control plate, sir?
control plane, data plane, not plate, control plane. If a firewall will decide based on
Yeah.
IP address and port number, then it cannot be a good firewall. Why? Someone can use different port number because that's the port number you permit. For example, what if I'm using a BitTorrent with UDP 53? What is UDP 53? DNS. DNS is an important service, so you permit it. What I'm doing as an attacker, I know you will be allowing port 53. So I'm an attacker. I'm using BitTorrent to do some sort of attack so that I can come and dump a lot of material unwanted material in your network. So I'm using BitTorrent. But if I use BitTorrent, you will find me. So what I do is I change my port number to DNS port number and I send the packet, BitTorrent packet. If it is a normal router, it will permit. Or if it is an old traditional firewall, it will permit, because the traditional firewalls, they cannot see inside content. They only see them, they match only with the port number and IP address, and they say, okay, allowed, permitted. You are a DNS, I allow you. But actually it is not DNS. It is BitTorrent. The next generation firewall easily find it out. How? The pattern, the application, the data, the content which is coming in the packet has got the signature of BitTorrent. Firewall will say, hey, don't fool me. I can see you, man. You are a BitTorrent. Just covering yourself with DNS port number. Easily it will stop. You know, the traditional firewalls can be fooled. The next generation firewalls, they work in all layers. They will see even the content and see whether this content is really matching with DNS. No, it is matching with BitTorrent. So, won't be allowed. Okay, now let us go to our today's topic, switching. Switches needs MAC address to decide the exit interface. The control plane of the switch uses the MAC address. What is the control plane? The forwarding decision maker is a control plane. On a switch, it's the MAC address. On a router, it's the IP address. The control plane uses IP address. Now, every switch maintains a table called content addressable memory, CAM table, or you can also call simply as MAC address table. MAC address table, both are same. CAM and MAC, you see. Put the C reverse. CAM, MAC, both are same. CAM table, MAC table. So switches got these computers connected. Let's say the switches got these computers connected. The first characteristics of switch is listening and learning. It listens and learns. What it listens and what it learns. Let's say the MAC address of this computer is AAA. These are the MAC address of these computers. And the port numbers means, every port on the switch has got a name. Let's say this is F0/1. F means fast Ethernet. 0/2, F0/3, F0/4, F0/5. This is how the names are given. 0 means the 0th slot. In the 0th slot, the first port, second port, third frame. Now, initially, the CAM table is empty, nothing. Let's say the first time this A is talking to someone called C. What will be the source MAC address? A. What will be the destination MAC address? C. When this packet arrives to the port number F01, it listens. Who listens? The switch port listens and learns the source port number, source MAC MAC address. Source MAC address is learned. You see, this field will be copied to the CAM table. It learns that F01 on F01 who is connected? He is connected. So by listening to the incoming frame MAC address, source MAC address, it learns the device which is connected. You see, this device has got A. It is also seen in the MAC table. A MAC address is seen. I was telling you, A is talking to CCC. Is there information about CCC here? No. If the destination is unknown, it will flood. So the switches flood traffic for unknown destination. That's another second characteristics of a switch. That's another characteristics of a switch. First characteristic is it listens to the incoming MAC address, source MAC address of the frame and learns the source MAC address against the port number to which the end device is connected. Secondly, when the destination is unknown, see that destination CCC is not available in the MAC table. When the destination is unknown, switches will flood. In another word, you can say switches will broadcast. Will broadcast. Flooding, broadcasting. Meaning it will send it to all the ports except from where it is coming. It is coming from here. It will send to everyone a copy. It won't send back, it will send to all other ports, all other devices. We call this flooding. It forwards the packet to all the other ports other than from where it is coming. This is only for unknown destination. So when this packet goes to B, it will drop. Why, you know? Because the destination address should match with its own MAC address, which is not matching. This will accept it, this will drop it, and this will drop it because the destination of the packet is not matching with their own MAC address. Now, let's say this guy is responding back. If it is a ping packet, there will be a echo request sent and the echo reply will come back. When the echo reply comes back, what will be the source of the packet? It's an echo reply. Who is replying? CCC is replying. To whom he is replying? AAA. Now when this packet approaches F03, again same story happens. On F03, it will listen and learn the MAC address CCC from the incoming source of the frame. And now where the packet needs to be forwarded, AAA. It checks the MAC table again. It knows that AA is connected on F01 and it forwards the packet. This time it is not flooding, it is forwarding to a specific port. That is what I want to write. Flooding or forwarding. When the destination was not known, it was flooding. That's for unknown destination. When it is known, it will forward. So the third characteristics of a switch is forward or filter. Let's learn how it is going to decide whether to forward or filter. One example here I have shown you. When the destination is known, it forwards. Let me make another diagram. And let's say this is connected to another hub. This is switch. And this hub is connected to two computers. Assume. Now, let's say the port number is F0/1, F0/2, F0/3. DDD is on F0/3. CCC is on F0/2. Let's say they were doing some conversation and the MAC addresses are already learned. Now, A wants to talk to B. What is the source address? A. It wants to talk to B. When this packet hits the hub will always flood. Hub will always flood. Why? Hub don't maintain any MAC table. So the flooding goes here as well as here. Please focus. The packet that went here to the switch made the switch to learn. I told you in the first point, it listens and learns. It learns that there is someone called A. A is connected on F01. It has learned. Now, the packet that went here will be received because the MAC address matches. Now, this wants to respond back. This is important. Listen. B want to respond back to A. What will be the source? B. What will be the destination? A. Now, when this packet goes and hits the hub port, hub will always broadcast, I told you. Now a copy goes to here as well as the switch. This is an important place. Please focus. Switch receives a frame. Switch listens always to the incoming frame. Now it learns another MAC address on the same port where AAA was learned earlier. Okay. Now, after learning that MAC address from the incoming source of the frame, now it looks into the destination where to forward. Who looks? Switch looks. And it finds that the destination is also on the same port. What will it do? Will the switch forward? Will the switch forward the packet that was coming here like this, take a U-turn and go? Oh, no. Why switch needs to forward? Hub itself would have forwarded already a copy. Switch won't forward. It will filter, FIL. You see? This is the scenario where the switch will filter the traffic. Why? Because it finds the source and destination are all in same port. When it is in same port, it cannot forward. When next time, let's say A is talking to CCC. When this packet goes to the hub will flood it. It goes here, it drops it because CCC is not matching with the local MAC address. The packet which is received on the switch, it checks the destination. CCC is on port number F02, so it forwards the packet here. This is forwarding. When the MAC address is known, it is forwarded. When the MAC address is unknown, it is flooded. When the source and destination MAC address are in same port, it is filtered. Three main functions of a switch: listening, learning, forwarding, filtering, and flooding. Any question? See,
So what is the difference between forwarding
when
and
this
filtering?
packet hits the switch, it see the MAC address, the source MAC address on F01, and it also see the same port with the destination MAC address. When A and BBB are in same port, where it can forward? It cannot forward to anywhere, no? Because the destination to which the packet needs to go is also on the same port. Whereas in this case, if A is talking to CCC, the source is on F01 when it is received, and the destination is on F02. It can forward. It can forward like this. But when the source and destination are in same port, where can it forward? Cannot forward anywhere. It will simply filter. In another word, it will simply drop. All right.
Okay, sir. Okay.
So we learned that the switches uses MAC address only, but there are some switches by default they are layer 2, but when you put this command IP routing, You are enabling layer 3. When we say switch, it is only layer 2. They don't have routing capability, meaning they don't maintain routing table. They don't look into the IP address of the packet. It's only the MAC address by default. It look into only the MAC address, as well as they don't have the IP info in the routing, like routing table. They have only the MAC table. That's by default layer 2. But multi-layer switches, we call it as a multi-layer switch. Even though they are layer 2 by default, you can enable the routing capability by typing this command IP routing. After you put this command, the switch will start behaving like a router. The switch will start maintaining a routing table. Now you should ask me a question by this time. I am expecting a question. It's a switch by default. Switches usually maintain only the MAC table. I said it's not a normal switch, it's a multi-layer switch. We can enable routing capability. So after you enable routing capability, it maintains a routing table. Now when a packet arrives, it can decide the path based on the destination IP address, because it is now having routing table. Because now we have enabled layer 3 capability. What question I'm expecting from you here is, okay, it has got routing table. What will happen to the MAC table? What will happen to the layer 2 capability? Is it still a layer 2 device, or it's changed to layer 3? That's the question I'm expecting from you. I was expecting from you to ask that, will it decide based on routing table, or will it decide based on MAC table? That was the question I was expecting. The other way of thinking is, what will be the control plane now? Will it be a routing table or the MAC address table? Answer is both. Both. You see, you got ports. Some of the ports you have changed into layer 3. For the traffic that entering into those ports, routing table will be used. For the other ports, which is still a layer 2, MAC table will be used. That's why we call it as a multi-layer switch, so that you no need to buy a router. All the switching job will be done by default. Along with that, a router's job will also be carried out by looking into the routing table. So instead of you maintaining 2 separate boxes, one for switching and another for routing, you just got only one box solution now. Both switching and routing in one single motherboard. One single motherboard, one single box. So the space is reduced much. Electric energy, you need to, earlier when you have router separate, two separate physical electric wires connected to two wall outlets are used. Two power cable need to be maintained. It takes more space in the rack. Now it is reduced to half. Earlier you had 10 routers and 10 switches. After moving to multi-layer, totally you have only 10 devices instead of 20. Definitely it's a big savings with respect to the space and the cooling energy that you need to maintain in the data center, the air condition. More devices, more air condition is needed to maintain the temperature inside the data center. So multi-layer switch has got both layer 2 and layer 3 function, routing as well as switching. More about multi-layer switch will come later. Today we focused on what is switching. Switching is forwarding the packet based on the MAC address. We call it as layer 2 traffic forwarding. Layer 2 forwarding is also called as switching, layer 2 forwarding. The device that does layer 2 forwarding is switch. That's why we call it as layer 2 device, layer 2 switch, layer 2 device. It maintains MAC table. It listens to the incoming frame source MAC address and learns it against the port number. When a packet is arrived, when a frame is arrived on a switch whose destination is unknown, switches will flood the traffic. Once the MAC addresses are learned, there won't be flooding, there will be only forwarding. Switches will also filter traffic if the source and destination are in same port. I just explained with a nice scenario. This is the use case. This is the only chance where you will have both source and destination on the same port. And also we learned that there's a switch called multi-layer switch. It is little costly because it has to do both routing and switching job. By default, it will have only switching capability. But by enabling the command, by putting the command IP routing, you can enable routing function, routers functionality. So you will see both MAC address table and routing table used by the switch. Whenever a packet is received on a layer 3 port, see, by default all the ports are layer 2, but here I cancelled layer 2 and made it as layer 3. For those traffic, routing table will be used. For the other traffics on the other ports, the default port, the layer 2 ports, MAC table will be used. Please ask me question. Are you comfortable with what we have seen about switches, switching? Santosh, are you there? Okay. Now, the other topics that we are going to learn in switching is a loop
Yes,
prevention
sir. Yes, sir.
protocol called STP, spanning tree protocol. In STP, we have various flavors. Whenever we got redundant port, there are chances the packet enters like this and loop like this. To avoid this loop, a protocol called spanning tree protocol is used. In the spanning tree, we have per VLAN spanning tree, rapid spanning tree, and multiple VLAN spanning tree. This is the next topic in switching that we are going to learn. Today what we learned is the fundamental, what is switching. Tomorrow we are getting into this loop prevention mechanism called STP. But in the middle, I'll also take you to another topic called VLANs. After just introducing this first flavor, STP, which is IEEE 802.1d standard. After starting this, after understanding this, I'll switch to another topic called VLAN, and then we'll continue with these three. That's the order in which we are going to do. This is the order in which we are going to do. But before that, we left something on subnetting. So we'll finish that subnetting, the left out, and then come back here. We'll learn STP, followed by VLAN, followed by the flavors of STP. Thanks.